Good people, we meet again. This time we're going to look at number systems. We've always dealt with a number system, and we're not probably made aware that it was a number system. We always did counting right from primary school. We learned to count from 0 to 10 and from 0 to 100 and stuff like that. We're not really made aware at that stage that okay, our counts were until when we probably dealt with the abacus. The abacus probably was the most basic way of introducing us to number systems, where everything, if you remember the abacus, everything was sets of 10, sets of 10. So our counting there was based on 10, 10 deci. So our counting system was always what? The decimal system. But I'm going to want to take a long route to show, because sometimes we assume that people know and understand what they're doing, but maybe people become animals of habit. They just do things without really being conscious of what they're doing. So I'm going to take a long route so that you can at least what? Try and delve into the what, into this number system and say why do we call it what, why exactly is it base 10, yeah? I want to try and highlight why we are saying our normal system has always been base 10. I've already alluded to the abacus, so I've said that the abacus was a developmental stage of us dealing with what, with counts based on 10. But then now let's take a simple example. Let's say we're saying if a man says I have one wife, everyone understands exactly what one means. Okay, if another man, say a farmer, says I have 35 cows, we probably all understand what 35 is. Now if I were further to say, all right, let's say if I'm gonna take a big number and say that I would love to see my cows expand to probably 127. Okay, so you know, these are, we've been told in junior high, this is, or in primary school rather, that these are units, these are tens, these are what, are hundreds. But then now let's look at what we mean when you say this has been based on what, on sets of 10. Let's just say I take this number 127. I want to take 127, eh? Or let me make it even bigger and say 1274. I'm going to take that number and say, you know what, this is our normal number. So this is our normal number. I don't understand these base things. So what is a base? I'm saying, okay, if we have our normal number, I want to emphasize, if we have the numbers we're accustomed to and we want to change them to a certain base, what we do is try and find sets of that base that you want to change our number to. So if I were to change a number like this to base 10, someone who's, I hear someone saying ridiculous. What does it mean? It's just that for purpose of clarity, I want to deal with this, so that when I say it's the same thing, you understand exactly what we're talking about, and also to understand this counting in sets that we're talking about. Let's take that. Let's say if I want to know how many tens I have, I want to make it sets of 10. So if I want to find the set of 10 here, I must divide by what? By 10. So if I divide by 10, all of us will agree that I'll have 127. These are the tens. These are tens. And we've got those 7 could not make what? Could not make tens. So these are what I would like to go back and say. Let me clarify a little bit there and saying we got tens, yes, but then we had a remainder from our division, and that was a remainder of 7, and this 7 could not make a set of 10. So we call it 7 units. All right. So we know this first number we get from the division gives us units. Now, among those tens, I can still get sets of tens, but what I'm effectively doing is I'm dividing by 10 to the original number. I'm dividing twice. Now, if I divide by 10 twice, I'm actually dividing by what? By 100. So it's like I'm looking at the original number and I'm trying to find how many hundreds are actually there. So what I do, I first found sets of tens. So all I'm trying to show you is that everything is based on what? On 10. I found sets of tens, I found 127 of them, and then I had, no, what did I do here? 127, it was supposed to be remainder. I'm sure people were screaming at me. It was supposed to be remainder of 4 units. Okay, our last digit there is a 4. Right, we got carried away with the 7 here. So our last digit there is a 4. It was a remainder of 4 units. Now, if I try to say, okay, I'm looking for further sets of 10 in the tens. Now, I'm looking for 10 among tens, 10 times 10. I'm looking for hundreds from the original set. So I we'll find if I divide 10 into 127, I will find that I've got 12. These are 12 hundreds. And these are 12 hundreds. But I had 7 that could not make 7 sets of 10 that could not make 100. So these are the tens. They were coming from the tens, so they can't be units now, they are tens. Now I say, okay, do we find any set of tens? Now, if I look at the rational number, I'm actually dividing it by 10 3 times. That is dividing it by what? By 10 to the power of 3. That is dividing by what? At this stage here, this is dividing by 10. This will be 10 to the power of 1. At this stage here, I'm dividing by 100. It's like I'm dividing by 10 twice. And then it's like I'm dividing by 10 3 times. So at this stage here, I'm looking for tens. At that stage there, I'm looking for hundreds. At this stage there, I'm looking for thousands. Do we have 10 going in there? I'm just explaining here, so I don't want it to confuse people. I just want people to understand what I'm doing. So when I say that we're looking for tens here, people are with us and we're on the same page. But otherwise, this is not really necessary. After dividing by 10 3 times, you appreciate that we're then looking for what? 5 for thousands. Now, 10 times 10 times 10 is 1,000. So 10 into 12 will give us 1. It's the same as 1,000 into 1,274. It's 1. Okay. But we're dividing we divided 10 into hundreds. So what we got was 1,000, 1,000. But we found that 1,000 among what? Among sets of hundreds. So what could not make 1,000 was the 2. What was the hundreds that were left? Okay, so I've made a big mistake here. I've forgotten to indicate that this is a remainder in each case. So I just put R there to say remainder. Okay, remainder 7 tens, remainder. So when you divide it, each stage we divide, whatever remains gives us whatever we're trying to find those sets from. So we're trying to find the sets of thousands from hundreds. So our remainders is there, hundreds that could not make those sets. Now I try and I say, okay, let's see if I can get further sets of 10 simply by dividing by 10 again. This is now 10 to the power of 4 here. Okay, that will be 10 times 10 times 10 times 10. It's like I'm looking for 10,000 in 1,274. I cannot find, but I could have simply said 10 into 1 and I could not find the what? 10,000. So this is what I could not find tens of thousands. 10 down. I'll say tau for what? For 1,000. And then this here is a remainder of remainder. We're looking for those tens of thousands among thousands. So whatever was left there, that one is 1,000 that could not make a set of 10,000. So now, if you look at this now, so it means now when I look at my number, when I've got 0 now, if I divide further by 10, then I'm looking for hundreds of thousands. But then if I divide to 0, I'll get 0. Now I'll keep getting 0. So it means I can't find anything anymore. So once I've got 0, I know I'm done. Now, what does it mean? It means that my number is actually made up of 1,200, 7 tens, 4 units. But you say, but we knew this already. This was 1,000. We've done this in what? So I say I'm going to take a long way around just to clarify what I'm trying to what I'm trying to make a point of here. So now you can see that therefore this number here, the most significant digit is the one that you find when you go deepest in finding your sets, and what you found first was the least significant digit. So when you write our number, we say we have 1, we have what? Let's first I want to do something here that's going to clarify what I'm trying to highlight. So now here we said at this stage here, this was 10 times 10 times 10 times 10. This is 10 to the power of, what call this? 10 to the power of 4 at that stage. This here would have been the stage where we are looking at 10 to the power of 3. 10 times 10 times 10. This here is 10 2 times 10 to the power of 2. And this here is what? 10 1 time. So our 10 is actually 10 to the power of 1. Our 100 is 10 to the power of 2. Our 1,000 is 10 to the power of 3, and our 10,000 is 10 to the power of 4, which I believe we know already. So now what we are saying here is we have 1,000 here, we have one set of 1,000, We have 2 sets of hundreds. We have 7 sets of tens. And we have 4 units. Now, this here, what you're basically saying is here we've got what? 10 to the power of 3. Why? Because 1,000 is 10 times 10 times 10. This here is 10 to the power. We could not find 10 to the power of 4. So 10 to the power of 2. This is 10 to the power of 1. And units 1 is 10 to the power of 0. Okay, everything to the power of 0, we know from mathematics, everything except 0 itself, everything else to the power of 0 is what? It's actually a 1. So 1 is the same as the word unit means 1. So now, what are we saying now? If we look at us doing exactly what we did in what? In primary school, the 10,000, the what was, sorry, I meant to say thousands here. I said thousand, but I didn't put an H to differentiate from the 10 there. Okay, so the thousands, hundreds, tens, units, we've done this from what? From early days in school. So now, but if we express it like this, because I'm sure at some stage in our lives, we've done what? We've done bases and exponents. Now we've done what you call powers. So now, if you look at these powers here, these are all powers of what? Powers of 10. All right, so now you can see why we're saying our base, we know the bottom number is the base and the top number is the exponent. Okay, if we look at what call this, it's always base to the power of exponent. So you can see that our base there is actually base 10. So this count is basically based on what is actually base 10. So if we now then say our answer there was one of these, we're writing from the most significant digit. So we had 1,000, we had 200, or 2 to the power of 10, with 7 tens, or no, not 2 to the power of 10, 10 to the power of 2, 2 times 10 to the power of 2. What am I saying? 2, 2 to the power of 10. Now we are saying here we've got 7 tens, which is 7 by 10 to the power of 1, and then we've got 4 units, was 4 by 10 to the power of 0 is 4 times 1. 1 is units, so there's 4 units. So now this here is us, we were going to a base, we're going to base 10, so we're looking for sets of 10. We said when you go to a base, we divide by from our normal to a base we divide by what? Divide by the base. Okay, so what we then do is we then take after dividing and finding ourselves, we take our remainders, and we've explained why this is the most significant, because this is where you're looking for the biggest number, for the highest power of 10. So whatever you have last is our most significant digit, and whatever you had first was our least significant digit. So when we write our number, we write it from the bottom going up. Okay, so this is how we have 1 times 10 to the power of 3, our base is 10, 2 times 10 to the power of 2, 7 by 10 to the power of 1, and 1, 4 by. So we found when you go to a base, we have to put that base as a footnote in front of a number. But now if you look at this, if we take our original number, this is our normal number 1, 2, 7, 4 is equal to 1, 2, 7, 4 base 10, which means that actually our number at this stage looks like our normal number system is the same as what? As base 10. All right, but we can't say from one answer we then, because we know we've done this already, we've always known this. So all I'm trying to do there is to highlight that base 10 is actually our normal. So let's take another number. Let's say we want to say a number like 78, just to differentiate the two. If I want to take this number, our normal number 78, to base 10, I divide by the base. We just said when we want to go to a base, we divide by the base. So divide the base 10 into 78, and you will see that you've got 7 tens with the remainder of, I know it's tens because I only divided once. I don't have to keep writing this, it will take me forever. So 7 tens with the remainder of 8. We know those 8 are the units, they could not make tens. We divide further, we know we're looking for hundreds, but we can't find hundreds because obviously there's no 178. But let's just say they were looking among tens. We did not find any hundreds, so what remained was the tens we started with. So this is 7 tens. So we said obviously the tens have got what are more significant than the what? Than the units. These are the units. So we write our number up, and as you can see, 78 is equal to, when we now go to base 10, 78 did not change. It remained 78 in base 10. So probably a futile exercise because we've always known this, but I hope not, because the idea is to basically put still our minds. I want to try and what I want to try to make sure that we understand that when we go to other bases, this might look useless now, but when we go to other bases, probably to assist to say why are we doing whatever we're doing. So let's take one last example. Let's say we take a number like what, 305, and we say, okay, 305, what are you in base 10? And 305 say, oh, you want me in a different base. You know me, this is an everyday number. You want me in something that you don't know. We assume we don't know base 10, so we didn't even know that our accounts were base 10. All we do is just divide by base 10. So we divide by 10, and therefore we say 10 into 305, and there is 30 tens there with the remainder. What cannot make tens is the 5s. Okay, then you say divide further, and then you say, okay, I've got 3. This is, I'm dividing further, I'm dividing twice by 10 twice. This is me finding the hundreds. So these are 300s with the remainder of 0. Well, 3 times 10 doesn't leave us anything to give us 30, or don't leave us anything. Then you say, okay, fine. Do we have thousands though? If we try to find thousands there, then this answer will be 0. No thousands. There's no way 300 has got 1,000. So that's a remainder of, these were what? These were hundreds. So these 300s. So we take our number up. We have, I'm fighting for space here. We take our number up, and our answer therefore becomes 305 is equal to, when we check what it is in base 10, is 305 in base 10. So I hope this clarified matters. We always knew this, but now we know why we are saying these are what? These are what? These are hundreds, these are tens, these are units. On the base exponent system, 10 to the power of 0 is a unit, 10 to the power of 1 is a 10, 10 to the power of 2 is 100, and we've got 3 of those. We've got what? 0 of those, and we've got 5 of those, and it's all nice and clear. I hope you understood that. I hope it will help, because the whole idea is to what? Is to get our foot into understanding base systems. So now we are going to say, okay, we have understood our what? Our first example there. Let's try and see if we can then now, I'll go on next to do the what? To do base 2, and then I'll try to do the what? To highlight the differences. In fact, it will be similarities rather than differences. But then see you when you're taking base 2. Hope you enjoyed that. Ciao.